All right, let's see. So we want to keep this. It's still not going to work. Oh my God. All right. Well, it's not going to let me write, so we're just going to pretend. The animal is a panther is what I want to keep. That's the hypothesis. It lives in the forest is what I want to change. So I want something true with an animal as a panther, but a different place where it could live. Some people argue it could live in an aquarium. I think that's the best wrong answer. I'm not looking for monkey because that would replace the hypothesis. But panthers can live in the zoo. So I think the best answer here is A. If we come down to question 8, and this is really the pause it and start it again. See if that helps. I want to keep the hypothesis. So a multiple of 6 and a multiple of 9. That's my hypothesis. And that hypothesis is true here. 6 times 2 is 12, and 9 times 3 is 27. So the hypothesis is the beginning part of this equation. What I want is the conclusion to be true, but different. So 12 plus 27 is 39. 12 plus 27 is 39. It's a true statement, but the conclusion is different because 39 is not a multiple of 6. So yes, this is true. There is a counterexample. The counterexample is 39. And the true reason is 39 is not a multiple of 6. So B is the best wrong answer, right? A multiple of 3, but a multiple of 6 is your best answer. Okay. Questions on that? Question number 10 is the last question that it's so weird when the chat pops up. Counterexample, right? So I want to keep the hypothesis. I need x squared equals 169, but I need a different conclusion. Which of these answer choices can I substitute in to make x squared equals 169 true, but not be positive 13? So it's not this answer. And it's not this answer. It's got to be the negative 13. Remember that all perfect squares have 2 factors, the positive set of factors and the negative set of factors. So x equals negative 13 is going to be your right answer here. So we're looking at that Jamboard. If we look at group 1's work, oops, actually, let me get a pen. Number 1 is the biconditional because the 16th president will always be Abraham Lincoln. Absolutely. So we just want to make sure we can write that with the if and only if in the middle. Number 3 is a biconditional because an even number can never be odd. This is true. My only thought is a counterexample might be 0. So 0 is not even and it's not odd. It's like a special case. So 0 could be our counterexample, but in general, I agree that even numbers are never odd and odd numbers are never even. 0 is just kind of the problem child in that. Number 5 is not biconditional because there are other days other than virtual learning. That is for sure. I just want to make sure you can write it with the if and only if. I don't know where my stylus went. And only if. Okay, so we got to be able to write it with that. Biconditional because authentic hasn't won in a year besides 2020. Absolutely. If you know anything about the Kentucky Derby, they're all 3-year-olds. So once you win, you're not eligible to ever run it again. All right. So let's see if we can find some examples that actually have the biconditionals written. This group looks like they did a bunch of good sticky notes. Number 1 is biconditional. Perfect. Nice. So I'm still looking for the directions right here will write the biconditionals with your group. So what I'm looking for is the actual biconditional statements. So let's see group 3. Number 1 can be written as a biconditional. So we're definitely great at identifying. That is for sure. Number 3 cannot, and we talked about 0 in that group. Number 5 can be written as a biconditional. Number 6, yes. Number 7, yes. I think maybe number 5 I had is no, but let's look at that. 12 is not a biconditional because athletes are getting paid higher than him. So this one, this is where we start thinking about stuff, right? This was the Michael Jordan. As of the day this statement was written, Michael Jordan was the richest athlete. He was still getting paid the most as of when I wrote this last year. But maybe that's changed now. I don't know. Maybe Peyton Manning is up there. Who knows? So the conditions do change. That is for sure. Here we've got some if and only if. So it is Abraham Lincoln, if and only if. This is what I was looking for, guys. This is perfection. And then it is not an odd number. It is not even. This is the conditional, right? So that's the conditional. It is Monday if and only if it is virtual learning. So we've got that if and only if in there. That's the biconditional. If Authentic won the Kentucky Derby, then it is 2020. Again, this is the conditional. How do I make it into the biconditional? We're looking for the biconditionals here. If it's Michael Jordan, then it is the richest athlete in the world. That is true. I'm looking for the biconditional. This is the conditional. Great work, guys. If it's Ariana Grande, then it's the favorite artist of 2020. And that was also true at the time. What I'm looking for is how do I write that biconditional with if and only if in between the P and the Q. Okay, so when we're writing the biconditional, we need to write it is Ariana Grande if and only if it is the favorite artist of 2020. Right? I think Billie Eilish was up there too. They were kind of tied when I wrote this last term. Number 3, or group number 5, we're just looking for biconditionals. Do you spot any biconditionals? I see the if and only if right here. That's fantastic. That's our biconditional. This is our conditional. I see the if and only if. That's fantastic. That's our biconditional. If it's Monday, if and only if it is virtual learning, that is fantastic. And then if and only if the favorite artist of 2020. That if and only if has to go in the middle, ladies and gentlemen. That's what we're kind of honing in on right here. And then let's see what group 6 has. Group 6 typed it out. So we've got the if and only if. That's perfect. So this is the conditional, and this is the biconditional. Next one, if it's the richest athlete in the world is Michael Jordan, then this is the conditional. My stylist is going crazy. And if and only if it is Michael Jordan, that's the biconditional. Okay. Questions on any of that? We all good with it? Okay. Let's see. What I'd like to do is give you an opportunity to do some IXL right now and make sure that everybody knows how to log into IXL. So if you go to I'm not on the school computer, so mine doesn't show up here, but up here in the left-hand corner, you should have a drop down of quick links. If you don't use the Launchpad and ClassLink, this is going to be more difficult for you. So use the Launchpad and ClassLink in that drop-down menu and see if you have an IXL icon. Go to IXL through this process, and it will authenticate you automatically. If you don't go through ClassLink, right, if you go some other way to get into Zoom, you can open IXL over here in another tab, and you can click IXL, and you can sign in. I think your sign-in is your school email, but not VB Schools. It's VB Students and no.com. So it's whatever your email is at VB Students and no.com. And then your password should be the first 2 letters of your last name and then your lunch number. So I want to make sure everybody can sign into IXL. I'm already there. If you're having a problem, message me in the chat so we can talk about it. Otherwise, oh, you guys shouldn't be seeing that. Those are scores from people. I want you to go to those I skills. So you're going to go to geometry. I'm going to give you about 15 minutes to work on these. All of the geometry Oh, it went away. Oh, because I need to be over here. So if you sign in through ClassLink, it'll automatically authenticate you. Maybe. You're going to go to the eyes. And this is kind of getting you a jump start on your homework for this weekend. You're going to do I 1, 2, 3, 5, and 6. They're the ones that are highlighted. So I 1, 2, 3, 5, and 6. If you want to do some of the ones that are not highlighted, you're welcome to. That'll give you extra credit. But IXL 1, 2, 3, 5, and 6. Remember, 2 of them to 80% and 1 of them, and 3 of them to 50%. So 2 to 80% and 3 to 50%. No? All right. So when we're in IXL, we want to go to geometry. Oops. Just regular geometry. And then to the eye skills. These 5 things should take you maybe an hour and a half or so. So don't leave them for the last minute. They're designed to help you just remember all the stuff we've already done. So the first 3 things should be crazy easy. Actually, all of them we've learned now. So identify the hypothesis. That's just the beginning of the sentence, right? So Deanna's attending a career fair. That's the hypothesis. That's the beginning of our sentence. And then the conclusion is the ending. They don't intersect. They do not intersect, right? This I1 shouldn't take you very long at all. And then if we go down to I2, those are counterexamples. Counterexamples take a second, and sometimes they get a little crazy. So if you're good at counterexamples, then this is probably a good one for you. If the utensils can be used to write, then it is a pencil. So I need some kind of writing utensil. So it can't be chopsticks, and it can't be spatula, and it can't be a ruler, because it needs to be able to write. So you want to keep the beginning of the sentence and change the end of the sentence. Keep the beginning of the sentence. I want a person who's good at math, but someone who is not an engineer. So Tyrone, who is good at math, is a chemical engineer. That's not different than an engineer. So Brooke, who is good at math, is an electrical engineer. So she's still an engineer. And then Rosa, a man who is not good at math. I need somebody good at math. So sorry, Rosa, that can't be it. Manuel, who is good at math, is a lawyer. So Manuel is good at math, and he is not an engineer. That's what I'm looking for. Keep the beginning and change the ending. So I need a fruit. Can't be a potato. And it has seeds on the inside. Strawberries don't have seeds on the inside. The fruit, and it has seeds on the inside. So an orange or a pear? Do I need both of them? Seeds on the inside. I don't know what the answer to that is. Do we think orange or pear? I feel like it could be either one. Oh, it doesn't have seeds on the inside. See, I'm overthinking it. It has to be the strawberry. Right? So but they're not on the inside. They're on the outside.
Oh.
Right? So I'm thinking the same thing. I'm forgetting I need to change that conclusion. I don't want something with seeds on the inside. I want something with seeds on the outside. Right? So sometimes these counter conclusions can be a little crazy. If a shape is a rectangle, then the perimeter is an even number. So I've got to figure out what the perimeter is here, right? Which means I've got to add those and multiply by 2, add those and multiply by 2, add those and multiply by 2, and see which one is not an even number. So these counter examples can get a little crazy. My brain doesn't want to do counter examples anymore, so I'm going to go to I3, right? Find the ones that are easy for you. If IXL starts giving you stuff that makes you a little crazy, You've got lots of options here, right? So come down to the conditionals. Maybe that'll be good for you. All right. This is going to give us some number line stuff, I think. If C is greater or equal to 3, then C is less than 4. Is the following conditional true? So if C is greater than or equal to 3, then C is less than 4. I think that is not true. If two angles have the same measure, then they are congruent. If they have the same measure, that's the definition of congruent. So I think that is true. Okay, so do all of the ones that are easy for you. Again, I want you to have 2 80s and 3 50s. I know IXL gives you some crazy stuff, so don't stress over it. Just move on to the next one when you get stressed out. Okay. I do want to talk about this biconditionals, so I'm going to stop for a second. So your homework tonight is this biconditionals puzzle piece, and then we're going to talk about these logic laws for the last 10 or 15 minutes of class. Did anybody start this biconditionals puzzle piece? Anybody want to talk about it? You can put it in the chat if you don't want to unmute yourself. Anybody want to look at any of the questions in here? I want to look at one of them, so I'm going to open it up and I'll share as soon as it's open. If you would like to open your copy, this is a great time to open your copy. Again, we're looking for biconditionals here. So we want the if and only if in the middle. I don't know why it's not writing on this. And then here we want to do the converse. Be careful. There's a negative answer in here, right? Write the converse and the biconditional. Remember the if and only if has to come in the middle. The if and only if has to come in the middle. This is making me so mad that it's not writing. Question number 5 is the one I want to talk about. So sometimes people don't remember that there are 12 inches in a foot. So there's a little helpful hint right here. If the table is 36 inches tall, then the table is 3 feet. The converse of that would be if the table is 3 feet tall, I've got to take that ending, that conclusion, and put it at the beginning. If the table is not 3 feet tall, I'm not looking for the contrapositive, so I'm going to cross off B. If I could cross off B, I would. And then if the table is 3 feet tall, that matches my conclusion, so that's part of my converse. If the table is 36 inches tall, it's my hypothesis, so I know it's not D. In these kind of questions, ladies and gentlemen, you want to slash as much trash as you can. So I've taken off B because I can't have the not, and I've taken off D because I don't want to start with a hypothesis. That leaves me with A and C. So I'm looking for that if and only if. The if and only if is in the middle, and the 36 inches is before the 3 feet tall, so that's good. Here, I've got the if and only if at the beginning of the sentence. Can I have if and only if at the beginning? Somebody say, oh no. So I know you're alive and awake. We're going to cross off C, okay? The only answer that's possible is A because it doesn't follow, the rest of them don't follow the right pattern. So use that kind of as you go through these. Are there any other ones that anybody wants to talk about? I know a couple people were working through this. No? All right then. Let's meet at our digital notebooks for the last 15 or 20 minutes of class. So open up that digital notebook where we were working on the biconditionals, this interactive notebook right here. And I want to do a little bit more of your homework with you. These logic laws. So up until now, we've been talking about things that are true and false, right? Is Abraham Lincoln really the 16th president? Are odd numbers even or even numbers odd? Who is the richest athlete? We've been talking about things that are true and false. We're going to shift gears now, and this is what we're really going to do on Tuesday, so it's kind of a preview. There is a video right here. I encourage you guys to watch it if what I say in the next 10 or 15 minutes is super confusing to you. We're going to move from true and false to valid and not valid. Those are two different things. Valid arguments follow patterns. Okay, so we got to think like a lawyer here. We don't care if our client is guilty or innocent. We just care if what they did was legal or not legal. Okay, it's kind of a difference. And that's why a lot of people don't like lawyers, because we're not really looking for the truth. We're looking for legal and not legal. So our first law is law of detachment. To detach something literally means to take it apart. So we're going to take that if-then conditional statement, that compound sentence, if P then Q, and we're going to separate it into two distinct sentences. We're going to take that P, that hypothesis, and make it a sentence all of its own. And then we're going to take the Q and make it a sentence all of its own. It has to follow this order, the P first and the Q second. You can't do it in the reverse. The converse does not work here, okay? So law of detachment only works P then Q in that conditional pattern. The contrapositive also works. So we know the contrapositive, we switch and negate. So when we take apart our compound sentence, our if-then sentence, we're going to take the conclusion and make it negative. And then we're going to take the hypothesis and make it negative. Again, here, this law only works in this direction. It's like a one-way street. You can only do P then Q, and you can only do not Q then P. And guys, you really need to just memorize this because it's going to get confusing, I promise. Our last law is law of syllogism. Law of syllogism. Syllogism is a crazy word. I see that double L, and I remember something is going to be double here, okay? We're going to have three different clauses. So we're going to have a P after the if, we're going to have a Q after the end, or after the then, and then maybe the Q repeats, and then we have a new clause, R. So in syllogism, something is going to repeat. Either the Q's are going to repeat across a diagonal, or the P's are going to repeat across a diagonal, okay? Not to make anything more confusing, but syllogism can also work in the contrapositive. So if my Q's slash out, the P and the R can switch and negate. And if the P's cross out, the R and the P can switch and negate. All of you are probably holding your heads right now going, oh my God, Miss Doherty, this is alphabet soup, P's and Q's and dots and squiggles and lines and arrows, right? So let's go down to slide 12 and see if we can make it make sense. We're only going to describe what we see right here. We're only going to do the blue boxes today. We're going to save the purple and the pink for Tuesday. So law of detachment, literally what you see there. You see one compound sentence, one if then statement becomes a P statement and a Q statement. Okay? So that if-then statement, that compound sentence turns into a P statement and then a Q statement with periods. Okay? So one sentence becomes two sentences. In the contrapositive, that if-then statement, we still start with the if-then statement. But this time it becomes not Q. That's one statement. That was supposed to be the squiggle. And not P. Period. Okay. In detachment, that if-then, the P becomes a sentence and the Q becomes a sentence. In contrapositive, the if-then turns into a not Q statement and a not P statement. They have to follow this pattern. In this third one, we've got three compound sentences. Three if-then statements. And something repeats. One clause repeats and gets crossed out. Okay. You don't have to type exactly what I've typed, but you need to type something that makes sense to you. Okay. Your heads are probably mostly swimming right now. So can we go to slide 13 or do you need a minute? They make a lot more sense when you actually put words to them. So if I'm a mom, then I have children. If I'm a mom, then I have children. I am a mom, period. I have children, period. In contrapositive, it would be if I am a mom, then I have children. If I don't have children, then I am not a mom. Right? So I've taken it and made it backwards. Here, if I have children, then I'm a mom. If I'm a mom, then I am tired. I don't need the I am a mom twice. I can just replace that and say, if I have children, then I am tired. Right? If I am a student, then I have homework. If I am busy, then I'm a student. The students cross out. If I am busy, then I have homework. Okay? It might not make a lot of sense, but it follows the law of syllogism. So in our last 5 minutes, let's go look at slide 13 and see if we can highlight this and make it make sense. Mark saves $30. He can buy a new video game. Mark saves $30. Therefore, he can buy a new video game. This is valid. It follows the right pattern. It might be false because Mark could spend his $30 on something else. Okay. So do you see that those are two different questions? Is it true or is it valid? Valid just means it follows this pattern, P then Q. So if we look at example number 2, if a quadrilateral is a rhombus, I'm going to bold that. That's my hypothesis. Then it's a parallelogram. Oops. Then it's a parallelogram. That's my conclusion. So if I'm going to follow this pattern, the P has to come first. The quadrilateral is a rhombus. The tools are not working right. And so the conclusion is that quadrilateral is also a parallelogram. That follows the P and then the Q, the P and then the Q. So this is valid and it happens to be true. Questions on that? You're going to need these notes for Tuesday. So let's look at a counterexample on page 14. I know we have 3 minutes and I'm trying to shove a whole bunch of information in your head. This is the counterexample, the non-example. So for detachment, we have to do P and then Q. Here, Miranda runs 4 laps around the track. That's P. She ran a mile. That's Q. If Miranda ran a mile, does she necessarily have to run 4 laps around the track? Well, I don't know. It may be true or it may not be true, but it's definitely not valid because you can't start with a conclusion and then work backwards to a hypothesis. You can only go on a one-way street from the hypothesis to the conclusion. So up here, let's write that. What's different? Detachment must go P to Q, not Q to P. Okay, whatever makes sense to you is what you need to put in here. This is kind of what makes sense to me. You have to go P to Q, not Q to P. It's a one-way street. It's not biconditional. You can't read it front ways and back ways. P to Q is the only way to go. So contrapositive is similar, but a little bit different. Slide 15, and I know I'm going quickly. Hopefully you guys are keeping up. If you're not, I need to stop and go back. Tell me, okay? Pregnant pause, okay. If you live in Texas, is my P. Then you live in the United States, that's my Q. James does not live in the US. That is the Q, and the super important part is this not right here. Okay. That not is the not Q. So I can turn the sentence around and drive the other way down my one-way street as long as I change the order and I put in those nots. So the contrapositive works. Okay. Contrapositive works. Which means on slide 16, the reverse cannot work. I can't go not P to not Q. Absolutely. I am also making a video of this. So what I'm going to do is I'm going to upload the video and you'll have these when you go to do your notes this weekend, okay? So contrapositive must go not Q to not P. It cannot go not P to not Q. Okay. It has to go this way. Absolutely cannot go this way. Okay, guys, it is 12:35. That is the end of our class. I am going to post this video, so look for this video in today's folder. It'll be right underneath the digital notebook where the assignment is. All right, I'll see you later. Have a great weekend.